Dear students, welcome to my YouTube channel. In this session, I am going to explain Module 4, which is curve fitting and statistical methods. Let's see the concept of curve fitting. Curve fitting is the process of constructing a curve or mathematical function which has the best fit to a series of data points. It means that we have to construct or find mathematical function to satisfy the series of data values or points. Here, for example, from an experiment, we get a table of data. Here, x1, x2, x3, so on, xn are input values, and correspondingly, y1, y2, y3, so on, yn are output values. So, we have a set of or table of data from the experiment. If we sketch these points in xy plane, here input values and these are corresponding output values, then a curve fitting means we have to draw a line or curve to join these points. For example, fitting a straight line means we have to draw a straight line to join all these points. Look at here, we have to draw a straight line to join these points, and it should be the best fit to the series of data, best fit to these points. Here, for example, fitting a straight line, y is equals to ax plus b. Here, y is equals to ax plus b is the standard form of equation of a straight line. So, fit this curve into these data points means we have to draw a straight line to join these points. It should be the best fit. It means that we can draw a straight line between any two points, or we can write a straight line anywhere in the graph, but our final straight line should be the best fit. How to say that this straight line is a best fit? We have to find the unknown constants a and b in the equation of straight line, or should be find out by least square method. Least square method means the sum of the squares of the residual is minimum. While finding unknown constants a and b, the sum of the square of the residuals is minimum. Here residual means what? Residual is the difference between observed value and estimated value. Look at the graph here. Here these points are the experimental value or observed value, and here I draw a straight line. Here also there is another value of y exists. So difference between observed value and this is mathematically estimated value. So difference between these two values is called as residual. Similarly, at each point we have to find the difference, that is called residual. Then square of the sum of all the residuals is denoted by s, and this s should be minimum. How to say that this s is minimum? So this square of the sum of the residual is minimum when their partial derivative with respect to a and with respect to b equal to 0. Here, differentiate this equation partially with respect to a once and another time with respect to b. Here we get, if we differentiate this term with respect to a, we get first equation. Similarly, if we differentiate this equation with respect to b, we get second equation. Next, here 2 is common. By dividing by 2 and splitting the summation, we get these two equations. And next, summation a x square, here a is constant, keep it outside, summation x square plus b is constant, summation of x, transfer this term to RHS, and similarly from the second equation, summation a can be written as a into summation x, summation b, here b is constant, here we have b into 1, summation of 1 means here n values we have, in the table we have n values, therefore it becomes n, and transfer this term to RHS. We get two equations. These equations are called necessary equations or normal equations to the equation of a straight line. These are normal equations to find the unknown constants in the straight line A and B. Is it clear? To fit a straight line y equal to ax plus b, we have to find a and b in the least square method. Least square method means it should satisfy these two normal equations. But to find these normal equations, another simple method is, look at here. Equation of a straight line can be written in the form y is equal to ax plus b can be written just reverse. Ax plus b equal to y, and put a summation. Apply summation on throughout the equation. A is constant as it is. X summation of x plus b is constant. And here into 1 means summation 1 means n equal to y here summation of y. And multiply x throughout the equation. Here a into x square plus b into x plus here is y, multiply x, x into y. Apply summation throughout the equation. A into summation x square plus b into summation x plus summation of xy. These two are the normal equations which are derived in the method of, same as derived in the method of least square method. So these are the necessary conditions. So from these two normal equations, we have to find the unknown constants a and b. But to find, to apply normal equations, we have to find these values. Summation of x and n means number of values available in the table. Summation of x means sum of x values, and summation of y means sum of y values, and summation of x square values and sum of their product x into y. So to satisfy these normal equations, we have to construct a table contains the values x, y, xy and x square. Here write down a value of x in the first column and find their sum of x. Similarly, write down values of y in the second column and find out their sum. We get summation of y. And find out the product x into y and write down here, and finally we find the sum of xy. And similarly here the value of x, so square, find out their squares and find the sum. We get summation of x square. Substitute all these values into normal equations. You will get two equations. You will get two equations in two unknowns. Here there are two unknowns are a and b. Two equations with two unknowns a and b. By solving these two equations in calculator, by using calculator, in a mode option, you will find equation of option. In that we can choose linear equations, two equations with two unknowns, and substitute the coefficients of a and b in both the equations. You will get the value of a and b. So substitute this value of a and b into the equation of a straight line y equal to ax plus b. That is the best fit, or straight line fits to the given data, in least square method. This is called curve fitting or fitting a straight line. Let's see one problem to fit a straight line. Here fit a straight line y equal to ax plus b for the following data. They are given a table of data, values of x and values of y. First write down normal equations for fitting a straight line y equal to ax plus b. Here these are the normal equations. You have to remember these two normal equations. It is very simple to derive normal equations. I already explained here. Just write down y equal to ax plus b in the form of ax plus b equal to y, and put summation symbol, and multiply x throughout the equation, and again apply the summation. You will get normal equations. So write down normal equations. Here n means number of values. Here there are number of values are 8, n equal to 8. Then construct the table. Here we need a summation of x. So write down the values of x and find the sum, and write down the values of y and summation of y. Here summation of y. Another term is summation of xy here. So find out their product xy, find the sum, and here there is summation x square. So find out x square values of square of these values, and find the sum. Substitute these summation values into the equations. You will get two simultaneous equations here, two linear equations with two unknowns a and b. So by using calculator, you will find the value of, you can find the value of a and b. So correct to two decimal places and substitute into the equation of a straight line, ax plus b, a value into x plus b. This is the required straight line.